6 ways of automatic grading in Bach. The most significant difference between Bach and other CAD software lies in its parameterization. Automatic grading is an important aspect that demonstrates the parameterization of Bach. When we open the size chart, we can see the grade differences of different parts in the size chart. Tick the Auto Diff option. The size chart can automatically calculate the measurements of other sizes. The calculation function built into the size chart can calculate the size data of other sizes. For example, I will create a part to demonstrate it. For the hip part, if its grading amount is for centimeters, then the sizes of other sizes can be calculated. For example, when we draw this frame, the length of the line from the size chart is referenced, and the grading amount will also be referenced simultaneously. Measure the length of this line, and you can see its grading amount. If we divide the size by 2, the grading amount will also be divided by 2. If we measure the grading amount, we can see that the grading data has already become half of the original. With the calculation, you can see that the grading amount will also be calculated. The second method is to automatically calculate the grading through proportional points and equidistant points. For example, create a proportional point of the line. Select the point at the 1/2 position of this line, and the grading amount here is also 1/2. Select the proportional point at the 1/4 position here. And you can see that the grading amount at this point is 1/4 of the entire line segment. Now, We use the equidistant points tool to divide the entire line segment into 4 equal parts. It can be seen that the grading amount at the quarter position of the equidistant points is also 1/4 of the total grading amount. If we divide this line segment into 6 equal parts, we can see that the grading amount at the points of the 6 equal divisions is also 1/6 of the grading amount of the entire line segment. These are the ways to calculate grading through proportional points and equidistant points. The third way of automatic grading is to directly input a fixed value for the line length. Input the grading value behind the fixed value line. By checking the mesh diagram, you can see that the grading has been automatically completed. The fourth method of grading is to use the method of referencing the variable table. Measure the length of this line. At the same time, add the length of this line to the variable table. We name this variable as A. Measure the difference in grade for the length of this line. We draw a square frame, and the length of the square frame references the value of variable A. It can be seen that the data of the grade difference has also been referenced. We measure this line segment and can know that the grade difference of this line segment is 2 centimeters. If we draw the height of the square frame as a variable and reference this line segment, we can see that the grade difference will also be referenced in the same way. If we modify the grade difference of this line, the grade difference of the other line segment will also be modified synchronously. This is the automatic grading achieved through variables. The fifth method is grading through angles. Input the grading amount after the angle value, and you can observe that the grading proceeds along the direction of the angle. The last method is to copy the grading amount of the original line segment synchronously through the copying method. First, I will draw a square frame with grading. Select the proportional points on the line and take out a part of the square frame. Check the grading mesh diagram. Copy out the above part. Check the grading mesh diagram again. It can be seen that while the pattern is being copied out, the grading amount is also copied out simultaneously.